Hello and welcome to Module 27, Working with Network Security Data. So now we are going to dive into a little bit more details about the actual alerts and how we can analyze these data. We're winding down towards the end of the semester, so there's one more module left. So a lot of this stuff we just want to get as much information as we can, but more and more you will learn this and you will be able to retain the concept when we do the actual labs. Because we will be using Squill and we'll be using the security onion to analyze the data. So you'll have a much better understanding when you'll do the hands-on portion of the labs. Anyway, but we do need to take some notes, so please have your Microsoft Word open to take some notes to prove that you have listened to the lecture. So we will cover three topics. We'll talk about the common data platform, investigating the network data, and enhancing the work of the cybersecurity analyst. All right, so let's begin. Now, when it comes to the security onion consists of the ALK. So please write these down. So the ALK components are Elastic Search, which is an open platform for searching and analyzing data in real time. We have the Logstat, which enables the collection of normalization of data. The index of it, this is to aggregate everything together. And then you got the Kibana, which gives us a graphical interface to the data that has been searched. Or you can have also Beats, which is a series of software plugins that sends different information to the Elastic Search data stores. So please take a picture of this as well. So what we want to do is we want to be able to get all the data, the alerts, the syslog servers, the PCAPs that we get from different software. And the ALK, what it does is it aggregates all that information and gives us what's important. That's what the ALK is for. Right? So data normalization is the process, please write that down, is the process of combining data from a number of sources into a common format. So as you can see, for example, the IPv6 address, you can, this address can be written in multiple ways. So is the MAC, so the MAC address, or so, and the data. So what the ALK may do is will normalize all of that for us into one format. It makes it a lot easier to process. Data archiving. It is not feasible to save all the data indefinitely. So at some point, you have to get rid of all data that you don't need. How long should you retain the data? Please write this down. Squill alert data will be saved, will be retained for 30 days by default. You can change that value in the securityonion.com file, in the configuration file. All right, so it all depends on the location, where is it stored. You can change that as much as you want, depending on how much time do you need to analyze the data. All right, we'll take a look at the data, converting data into a universal format. We'll take a look at that in the lab. All right, now let's look at investigating the network data itself. Okay, so take a picture of this. I mean, we do know, we are familiar, hopefully, with the Squill dashboard. So, you know what, you don't have to do it, because I think you did that before. But if you did, that's fine. So the first thing you are going to do is, as a security analyst, is come to Squill. Look at the alerts, all right, and look at the STs to see which one are red. So you want to probably sort them out into from red to it, because you want to take at the most important ones, and ones that have priorities. Okay, so the ones with the red, the status with the red, is the one that you want to take a look at first. Okay, so all the queries. So here we go. We all the queries were constructed and built. So look at all the reds first, so you can analyze each one of them separately. Okay. All right. So now that you got from Squill, you got all the alerts, and let's say you got all the red ones, and you want to take a look at it. You can right-click on them, and you can pivot to another platform, right? So Squill will allow you to pivot to other tools, right? Log files are available in Elasticsearch. You can actually use you can use Wireshark, or you can use Kibana from the alert to get more detail about the actual attack. And we will practice that in class. And our skill-based assessment at the end of the semester will be able to use a Squill, look at an alert, and analyze it. Okay? So you have to be able to use Squill and be able to pivot to maybe Kibana or Wireshark to analyze the data that is being given to us from the alert. All right. So Squint constantly enables the cybersecurity analyst to investigate, verify, and classify alerts. Right. So the 3 tasks completed in Squill to manage alerts. So please write these down. Alerts that have been found to be false positive can be expired. An event can be escalated by pressing F9 key, and an event can be categorized. You can do all of that, right? So they do have a pre-built categories, by the way. All right. So Logstash and Beats are used for data ingestion in Elasticsearch. Kibana, which is the visual interface, this is similar to Wireshark, into logs that is configured to show at the last 24 hours by default. You can change that. So you got to make sure you double check. It may be longer than that depending on the attacks. So when you're doing LAD, you look, sometimes you may have to go a month or two prior, depending on when, because Kibana will not show even if the alert happened prior to 24 days or 24 hours, it will not show up. Kibana will not be able to analyze it. So you may have to change that default. So please write that down so this way you can remember it. So Kibana is a visual interface into the logs and is configured to show only the last 24 hours by default. All right. Elasticsearch is built into the Apache Lucene, an open source search engine software library featuring full text indexing and searching capabilities. They use the JSON query language, and along with JSON, Elasticsearch queries make use of elements such as Boolean operators and so on. Okay, this is all good to know. Moving on. Okay, now, investigating the processes or API calls. And application programming interfaces is what an operating system puts out, codes or protocols that application may use to enable them to work with the operating system. So all applications, they contact the APIs, and it's the APIs that allow these specific applications run on the operating system. Right? So please write that first sentence down and write the second bullet point as well, and the third, and the fourth. You know what? Write all of them down. Because if a malware can fool the operating system kernel to get into and have access, so if there is someone being able to use the APIs to get into the operating system and have access to the hardware, input-output devices, the network, and the processes, they'll be able to do that. But the OSSec will be able to detect these changes in the host-based parameters. according with the API, and immediately trigger an alert in Skrill. And then you'll have to be able to analyze that alert either using Kibana or something else, maybe Wireshark. So you'll be able to be able to analyze that data and see what happened. All right, the actual file details, as you can see, this is from Kibana, the interface from Kibana, the dashboard stuff. And again, we'll take a look at this into a little bit more details when we're doing our labs. Okay, so in Skrill, the cybersecurity analyst is suspicious of a specific file. The hash value can be submitted to the online to determine if this file is a malware or not. So if you have a suspicious file, you can actually upload it, and you can see if this file uploaded to to an online site to see if this file is malware or not. In Kibana and Zeek, the hunting can be used to display information regarding the files that have entered onto the network. And by the way, I don't know if this is important or not, but now we call these new names, instead of it's Zeek, the new names for them. All right, so moving on, we'll be able to do all of these labs, and please watch these videos. They are very, very helpful in understanding the content of what we're doing. So these videos on lab we will have to go over. So we're spending more time in the last two chapters, more on the hands-on, and that's how you're going to retain this information a little bit better. All right, now enhancing the work of the cybersecurity analyst. Okay, so we want definitely to have dashboard that will give us combinations of data and visualization, which allows the cybersecurity analyst to focus on a specific data. So dashboards are very, very important. Kibana includes the capability of designing custom dashboards. So all of that is very, very important. And definitely workflow management. So a workflow management is a sequence of processes and procedures through work tasks that are completed. So you definitely need to do that. So please write down these 3 bullet points. Managing the SOC workflows. Enhances the efficiency of the cyber operations team. Increases the accountability of the staff. And it will ensure all potential alerts are treated properly. All right. So Skrill does provide us, but it's not good for large operations. So you really have to find a process and a procedure through how the workflow management would work. So automated queries add efficiency to the cyber operations workflow. So these queries automatically search for complex security incidents and may evade other tools. But you have to have some sort of a work management tool available. All right, so this chapter was pretty quick. So please upload those notes that I asked you, and I'll see you on the last module, module 28.